Biofuel is a fuel that is produced through contemporary processes from biomass, rather than by the very slow geological processes involved in the formation of fossil fuels, such as oil. Since biomass technically can be used as a fuel directly, some people use the terms biomass and biofuel interchangeably.
I'm Professor Scott Williams, and I serve as the Managing Director of the Omaha Biofuels Cooperative. The co-op has partnered with Metropolitan Community College to develop biofuels capabilities here in Omaha, to consult on biofuels implementation, and to provide education about biofuels. Today I'm going to be discussing and demonstrating the production of biodiesel from vegetable oil. Even though the reaction has a complicated sounding name, it's fairly easy and straightforward to demonstrate. As you can see here, most of the equipment could be found around the house. The reaction involves three main ingredients, or reactants: vegetable oil, methanol, or methyl alcohol, also known as wood alcohol, sourced from a common gasoline fuel additive, and a catalyst, which is lye, often used in homemade soap making. Both methanol and lye should be used with appropriate precaution, including personal protective equipment. Methanol is volatile, flammable, and toxic with contact on skin. Lye is highly caustic, dissolves many materials, and also produces chemical burns immediately on contact with skin. I'll be wearing a long sleeve lab coat, goggles, and laboratory gloves. The recipe used today will be 200 milliliters of cooking oil, 50 milliliters of methyl alcohol, and 4 grams of the catalyst lye. To start, we need to warm up the cooking oil, which I've already begun here using our modified Mr. Biofuel. Now that the oil is nearly warm enough, we can start with the other reactants. We'll add a weigh boat to the scale and tare or reset the scale to 0, and then weigh out 4 grams of the catalyst lye. Next, we'll measure 50 milliliters of the methyl alcohol into our flask. Next, we'll dissolve the catalyst into the methanol, making a meth oxide solution. The dissolution reaction is exothermic, meaning it produces and gives off heat. At a larger scale, it can even produce dangerously high levels of heat, getting to above the point of boiling for methanol, which is 148 degrees Fahrenheit, significantly lower than the boiling point of water. We're going to use a magnetic stir plate to help provide mixing. In the base is a motor attached to a magnet. The magnet can magnetically couple to a magnetic stir bar, and when the motor rotates, the stir bar rotates, providing mixing. Next, we dissolve the catalyst into the methanol, making a meth oxide solution. It'll take about 3 minutes for all of the lye to dissolve into the methanol, forming the meth oxide solution. Now that the lye is mostly dissolved into the methanol, we can remove the stir bar. We'll measure out 200 milliliters of the heated cooking oil into our reaction vessel. Today we're using a mason jar. We'll place the jar on the mixing plate and add a stir bar. To make the reaction happen, we need heat, which we provided by adding it to the oil, and mixing, which we get from the magnetic plate, and time. We need to make the reaction happen with heat, but it's critically important to make sure that the temperature is not above the boiling point of the methanol, or else a violent eruption can take place when we mix the reactants. For this, we're using a standard digital kitchen thermometer. As I mentioned previously, the boiling point of the methanol is 148 degrees Fahrenheit. So we just need to stay below that with the cooking oil. Cooking oil is significantly darker than the vegetable oil, and it'll make the entire mixture start to appear dark. Now that we've given enough heat, mixing, and time for the reaction to take place, we'll stop the mixing. We need to let the glycerol settle down to the bottom. Glycerol has had time to separate and settle out of the biodiesel, leaving two distinct layers clearly visible. In about 24 hours settling time, the biodiesel would appear completely clear and all of the glycerol would be down at the bottom. With a valve at the bottom of the container, we can drain away the glycerol and leaving just the free biodiesel on the top. The byproduct glycerol can be useful in the process of making soaps. The last step would be to wash away any residual reactants or contaminants in the biodiesel, such as soap. Then the final fuel is ready to use. Biodiesel is a drop-in replacement for petroleum diesel in any diesel engine application. Cars, vans, trucks, trams, trains, semi-trucks, generators, even heating applications. Biodiesel burns cleaner at the tailpipe, emitting less soot and less air pollutants. With no sulfur in the fuel, there's no sulfur oxides released from the tailpipe, which can contribute to smog and acid rain. Since biodiesel is produced from biosources, it's a net zero carbon cycle, and there are no contributions of CO2 as a greenhouse gas that can cause global climate change. Biodiesel can be made from recycled sources, including used cooking oil, and can be produced domestically, even locally, right where it's needed and used. Stay in touch with Metropolitan Community College and the Omaha Biofuels Cooperative to keep learning more.
Biodiesel fuel with the help of cyanobacteria, producers of fatty acids, was learned by biologists of the Research Institute of Biology and Biotechnology of Al-Farabi, Kazakh National University. The project manager is Doctor of Biological Sciences, Professor Zayadan. Cyanobacteria or blue-green algae are insect bacteria capable of full photosynthesis. It is believed that cyanobacteria releasing oxygen in the process of vital activity 2 billion years ago created the modern atmosphere of the earth. Bacteria are also able to bind atmospheric nitrogen and include in the biomass. It was this ability of microorganisms that Almaty biologists used. And now we show you video about technology of receiving biodiesel.
Operation. Therefore, we make sure that people have the correct PPE, competency, training and knowledge. Both facilities import used cooking oil from ship and ISO container from all over the world. We also import locally throughout the UK. When the oil first arrives on site, a sample is taken from the shipment or road tanker to our on-site lab to make sure it complies with our strict purchasing specification. The process of manufacturing used cooking oil and converting into biodiesel can be split into 4 simple stages. The clean-up stage consists of a series of chemical dosing, heat exchangers and centrifugation where we clean up and filter the impurities for the next stage of the process. The centrifuge is a high-speed rotating piece of equipment that cleans, washes and filters the used cooking oil. From the deodorizer and refining process there are 2 distinct streams, one of them being refined oil, which is later converted into biodiesel, and the other one is free fatty acid, which again is reused further within the process for conversion. Within the deodorizer, the washed used cooking oil enters a series of trays. Within these trays there's a series of weirs and holes. Steam is sparged into this oil, breaking the surface and condensing the free fatty acid, pulling it down into a central chimney where it is recovered for processing further on in the conversion. The transesterification process is where the refined oil is converted with methanol in the presence of a catalyst. Within the process, the glycerin and the biodiesel have different densities. By reactors and separation throughout the process, we can recover these two streams. The final product is dried, centrifuged and sent to our storage tank. Because of the heat generated within the process, we use economizers, which are oil-on-oil heat exchange. It makes the plant more efficient, reduces our power consumption and reduces steam usage. In this final part of the process, we recover unused reagents, wash waters and other byproducts for further conversion or reuse. The methanol system recovers the unused methanol reagents through a vents header system, which is linked across all the process vessels, where the excess methanol is dehydrated and returned for reuse through the transesterification process. The water phase recovered from the methanol column is utilised as process water through the rest of the plant.
Today I will speak about advantage of biodiesel. Biodiesel as a fuel has the following advantage, as like as the emission of sulfates, carbon dioxide and solid particles into the atmosphere is reduced. It burns almost without releasing toxic and carcinogenic substances into the environment. Next advantage is the amount of soot is reduced by almost 2 times. It doesn't have a pungent smell. When it hits the ground, it decomposes by microorganisms within 3 weeks. Next advantage is the low sulfur content and high level of flammability, less flammable. And the last advantage for today is the good lubricantic characteristics.
Despite the advantages of using biodiesel, it also has a number of disadvantages. First is the fuel has solvent properties, therefore it is aggressive to use in giant parts. Second disadvantage is the efficiency of biofuels decreases in the cold season. At low temperatures, sediment appears, which leads to cooling of parts and contamination of filters. The third of disadvantage is if biodiesel gets on the car body, it must be thoroughly whipped, since such fuel decomposes the paintwork. The next of disadvantage is short shelf life. Unlike conventional gasoline according to maps. And the next disadvantage is the need for a large areas of land for growing raw materials for biofuels.